Have you ever wondered why two bakers can follow the exact same recipe, yet one produces soft, fluffy bread while the other ends up with a dense and hard loaf? The secret isn't just the recipe, it's understanding the ingredients. In today's lecture, we'll explore the science behind wheat, flour, yeast, chemical leavening agents, salt, and flavoring ingredients used in bakery and confectionery products. By the end of this session, you'll not only know the function of each ingredient, but also understand why selecting the right ingredient is the key to producing high-quality baked products. Let us begin by understanding why wheat is known as the global cereal king. Wheat is the most widely cultivated cereal grain in the world and serves as the foundation of the bakery industry. Almost every major baked product, including bread, cakes, biscuits, pastries, and pasta, begins with wheat. The slide introduces three important types of wheat. The first is hard wheat. Hard wheat contains a high amount of protein, particularly gluten forming proteins. Because of this, it develops a strong gluten network that gives bread its elasticity, structure, and excellent loaf volume. The second type is soft wheat. Soft wheat contains comparatively less protein and develops weak gluten. Instead of producing chewy bread, it creates soft and tender bakery products such as cakes, pastries, muffins, and biscuits. The third type is durum wheat. Durum wheat is extremely hard and rich in protein. However, its gluten behaves differently from bread wheat. It is mainly used for manufacturing pasta, macaroni, vermicelli, and semolina products because it provides firmness after cooking. The image shown on the slide compares these three wheat varieties. Although all belong to the wheat family, each variety has its own unique characteristics and specific industrial applications. Now let us understand the characteristics of hard wheat in detail. The first characteristic is high protein content. Hard wheat contains a greater amount of gluten-forming proteins than other wheat varieties. These proteins produce strong and elastic dough that can hold gas efficiently during fermentation. The second characteristic is high water absorption power. Hard wheat flour absorbs and retains more water while preparing dough. This improves dough consistency and also increases the final bread yield. The next property is excellent mixing power. The gluten network developed from hard wheat can tolerate prolonged mixing without breaking down. This makes it highly suitable for commercial bakery production where mechanical mixing is extensively used. Another important property is high tolerance. Tolerance refers to the ability of flour to withstand prolonged fermentation without losing dough stability. Even after extended fermentation, the dough remains stable and continues to retain its structure. The next point is superior gas retention. During fermentation, yeast produces carbon dioxide gas. The strong gluten network formed by hard wheat traps this gas efficiently, resulting in soft bread with high loaf volume. Finally, the slide mentions coarse texture. Hard wheat kernels are physically harder and more granular than soft wheat. This property contributes to the production of strong flour suitable for bread making. A simple way to remember hard wheat is this: it provides strength, elasticity, and volume, which is exactly the qualities needed for good bread. Having understood hard wheat, let us now study the characteristics of soft wheat. The first characteristic is low protein content. Because soft wheat contains less protein, it forms only a weak gluten network. As a result, the final bakery product becomes soft and tender rather than chewy. The second characteristic is low water absorption power. Soft wheat absorbs less water than hard wheat, producing softer doughs and smooth cake batters. The next property is poor mixing tolerance. Since gluten development is limited, excessive mixing quickly damages the structure. Therefore, cake batters and pastry doughs should be mixed gently to obtain the best texture. Now let us look at its physical characteristics. Soft wheat has a smooth texture and its flour tends to form fine particles that easily clump together. Finally, the slide highlights its primary application. Soft wheat is ideal for cakes, pastries, biscuits, cookies, muffins, and similar bakery products where tenderness is more important than elasticity. Here's a simple question for you. Why isn't bread made using soft wheat flour? Think about it for a moment. The answer is that bread requires strong gluten to trap carbon dioxide during fermentation. Since soft wheat develops weak gluten, it cannot produce the desired loaf volume. Now that we understand the different wheat varieties, let us study the structure of a wheat grain. The first component is the bran. Bran is the outer protective covering of the wheat kernel. It is rich in dietary fiber, vitamins, minerals, and antioxidants. Although highly nutritious, excessive bran particles can interfere with gluten development. The second component is the endosperm. Endosperm forms nearly 83% of the wheat grain. It contains most of the starch and protein used in flour production. Refined flour is prepared mainly from this portion. The third component is the germ. Germ is the living embryo of the seed. It contains healthy fats, proteins, vitamins, minerals, and enzymes that support germination. Because it contains oil, flour with germ has a shorter storage life. Finally, the slide mentions milling goal. The purpose of milling is to separate these three components in different proportions to produce different types of flour, such as refined flour, whole wheat flour, and specialty flours. The diagram on the right clearly illustrates the layered structure of the wheat grain, showing the bran, endosperm, and germ. Understanding this structure helps us understand why different flour types vary in nutrition and baking performance. Now let us understand how flour quality is evaluated. The first quality parameter is color. Good quality flour should have a clean creamish white appearance. This coloration may indicate poor quality wheat or improper storage. The next parameter is light reflection. Fine and high quality flour reflects light uniformly because of its smooth particle size and purity. Another important process mentioned is bleaching. Bleaching improves the whiteness of flour and provides a more uniform appearance, particularly for cake flour. The second major quality factor is flour strength. Flour strength depends mainly on the quantity and quality of gluten proteins. Strong flour contains more gluten and is therefore preferred for bread production because it forms elastic dough capable of trapping fermentation gases. Weak flour contains less gluten and is suitable for cakes, pastries, biscuits, and confectionery products where softness is desired. Whenever you are asked about flour quality in examinations, remember these two major parameters: appearance and gluten strength. Now let us discuss two more important properties of flour. The first is tolerance. Tolerance refers to the ability of flour to withstand prolonged mixing and fermentation without losing dough stability. Good tolerance allows gluten to mature properly while maintaining dough strength throughout processing. This characteristic is especially important in industrial bakeries where dough often undergoes extended mechanical handling. The second property is water absorption power, commonly known as WAP. Water absorption power indicates the maximum amount of water that flour can absorb while still producing workable dough. Higher water absorption generally results in better bread quality, increased loaf volume, and greater production yield. Finally, the point mentioned is uniformity. Uniformity means every batch of flour should consistently behave during mixing, fermentation, and baking. This ensures standardized product quality and customer satisfaction. In commercial bakeries, consistency is just as important as quality because consumers expect every loaf of bread to have the same taste, texture, and appearance.
Having understood flour quality, let us now study the different types of flour obtained from wheat. The first type is whole wheat flour. Whole wheat flour contains all three parts of the grain: bran, germ, and endosperm. Because nothing is removed, it is rich in dietary fiber, vitamins, minerals, and other nutrients. The second type is bread flour. Bread flour contains approximately 12 to 14% protein. This high protein level develops strong gluten, making it ideal for yeast-raised bread. The third type is all-purpose flour. All-purpose flour contains about 10 to 12% protein and is prepared by blending hard and soft wheat. It is versatile enough for most household baking applications. The fourth type is cake flour. Cake flour contains only 7 to 9% protein. It is finely milled and often bleached, producing soft, delicate cakes with a fine crumb structure. Finally, pastry flour contains 8 to 10% protein. It provides slightly stronger gluten than cake flour and is mainly used for pie crusts, pastries, and similar bakery products. Always remember that different bakery products require different gluten strengths. That is why bakeries use different types of flour instead of relying on just one. Now let us move to another important group of bakery ingredients: milk products. The first product is cream. Cream contributes richness, fat, and a smooth mouthfeel to bakery fillings, frostings, desserts, and garnishes. The second product is yogurt. Yogurt provides moisture, slight acidity, and also supports certain biological leavening processes while improving flavor and texture. The next dairy ingredient is cheese. Cheese is widely used in savory baked products, cheesecakes, stuffed breads, pizzas, and specialty confectionery products because of its unique flavor and texture. Another essential ingredient is butter. Butter is often called the gold standard of bakery fats because it produces excellent flavor, tenderness, flakiness, and premium quality baked products. Finally, we have koa. Koa is prepared by concentrating milk solids and is extensively used in traditional Indian sweets as well as modern fusion bakery and confectionery products. The images shown on the slide represent these important dairy ingredients, highlighting how each one contributes not only nutrition, but also flavor, richness, texture, and overall product quality.
Now that we have understood the major ingredients used in bakery products, let us move to one of the most important biological ingredients in bread making, yeast. The scientific name of baker's yeast is Saccharomyces cerevisiae, which literally means sugar-eating yeast. It is the essential biological engine that drives the bread-making process by producing volume, aroma, and taste. Let us first understand its biological nature. Yeast is an egg-shaped, single-celled fungus. Although it performs a huge role in baking, each yeast cell is microscopic and can only be seen under a microscope. Commercial baker's yeast is carefully isolated and grown under controlled conditions to maintain its quality and activity. The slide also highlights an interesting fact. Approximately 20 billion yeast cells are required to weigh just 1 gram. This shows how incredibly small each cell is, yet together they produce enough carbon dioxide to raise an entire loaf of bread. So, although yeast is microscopic in size, it has a tremendous impact on the structure, flavor, and quality of bakery products. Now let us understand the core functions of yeast during bread making. The first function is rising the dough. During fermentation, yeast converts sugars into carbon dioxide gas. This gas becomes entrapped inside the gluten network, stretching the dough just like inflating a balloon. As more gas is produced, the dough expands, resulting in a soft and fluffy bread. The second function is dough development. Fermentation not only produces gas but also strengthens the protein structure of the dough. A stronger gluten network can retain more carbon dioxide, producing bread with better volume and texture. The third function is improving sensory appeal. Yeast produces several flavor and aroma compounds during fermentation. These compounds give freshly baked bread its characteristic smell and delicious taste. At the same time, fermentation contributes to the final texture of yeast-raised products. Whenever you enjoy the aroma of freshly baked bread, remember that much of that pleasant flavor comes from the activity of yeast during fermentation. Next, let us study the fermentation process step by step. The first step is metabolism. Yeast cells begin consuming the starches and sugars naturally present in the flour. These nutrients provide the energy required for yeast growth and fermentation. The second step is byproduct formation. As yeast multiplies, it produces two important byproducts, alcohol and carbon dioxide gas. The third step is expansion. The carbon dioxide gas fills the tiny air cells within the dough. These gas bubbles expand, causing the dough to rise and become light and airy. The final step is baking.
When the dough enters the hot oven, the alcohol evaporates and the carbon dioxide escapes as vapor. Meanwhile, the gluten structure becomes fixed, giving bread its permanent porous texture. This entire process transforms a dense dough into the soft, light loaf that we see after baking. Now let us understand the life cycle and growth requirements of yeast. The first requirement is optimum conditions. Yeast needs sufficient moisture to become active. It also requires a warm temperature because warmth accelerates its metabolism. In addition, yeast grows best in a slightly acidic environment. The next stage is multiplication. Once activated, yeast cells divide rapidly inside the dough. This multiplication continues as long as enough food, mainly sugars, is available. Finally, let us look at the last stage. When the dough is baked, the high oven temperature kills the yeast cells. This stage is called thermal death. Although the yeast becomes inactive, the bread structure has already been formed and becomes permanently set during baking. So yeast remains alive only until baking begins, after which its job is complete. Having understood how yeast functions, let us now study the different varieties of fresh yeast. The first variety is compressed yeast. Compressed yeast has a soft, crumbly texture and contains a high amount of moisture. It is widely used in commercial bakeries because of its excellent fermentation activity. The second variety is cream yeast. Cream yeast is available as a liquid suspension and is generally used in large-scale automated bakery operations. The next point is storage. Fresh yeast should always be refrigerated at about 40 to 45 degrees Fahrenheit to maintain its activity and extend its shelf life. Finally, good quality fresh yeast has a pleasant apple-like aroma. This fresh smell indicates healthy and active yeast suitable for baking. The image on the slide shows different forms of fresh yeast used in bakery production.
Now let us study the different varieties of dry yeast which are widely used because of their long storage life and ease of handling. The first type is active dry yeast. Active dry yeast contains dormant yeast cells that require proofing or rehydration before use. It is usually mixed with warm water so that the yeast becomes active before it is added to the dough. During manufacturing, it is often blended with cornmeal and then carefully dried to improve its stability. The second type is instant dry yeast. Instant dry yeast consists of fine granules that dissolves rapidly in the dough. Unlike active dry yeast, it does not require proofing and can be mixed directly with flour. However, it is sensitive to sudden temperature changes, so it should be handled carefully. The next point is shelf life. Because of its very low moisture content, dry yeast is extremely stable and can be stored for about 4 to 6 months under proper conditions. Finally, let us look at its appearance. Dry yeast generally has a grayish-brown color with a characteristic pleasant aroma, which indicates good quality yeast. Both active dry yeast and instant dry yeast are commonly used in bakeries, but the choice depends on the production method and convenience. Next, let us understand some specialty types of yeast used in commercial baking. The first is rapid rise yeast. Rapid rise yeast contains smaller granules that dissolve much faster than normal dry yeast. Because of its high activity, it produces carbon dioxide rapidly, allowing the dough to rise in a shorter time. However, the slide also mentions an important limitation. Since fermentation occurs more quickly, there is less time for flavor compounds to develop. As a result, bread prepared with rapid rise yeast may have slightly less flavor than bread produced using normal yeast. The second type is deactivated yeast. Deactivated yeast consists of dead yeast cells, so it has no leavening ability and cannot produce carbon dioxide. Even though it cannot ferment, it serves as a powerful reducing agent that improves dough extensibility. This makes it useful in products such as pizza dough and pan bread, where dough stretching is important during processing. The image shown on the slide compares rapid rise yeast and deactivated yeast used in bakery industries. Before we move to the next topic, remember this simple point. Living yeast is used to produce carbon dioxide, whereas deactivated yeast is mainly used to improve dough handling properties. Now let us move to another important method of producing gas in bakery products: chemical leavening agents. Unlike yeast, chemical leavening agents do not involve microorganisms, instead, they produce carbon dioxide through chemical reactions. The first point is the core mechanism. Chemical leavening agents react with moisture and heat, or sometimes with an acidic ingredient, to release carbon dioxide gas. This gas expands the batter or dough, making the final product soft and porous. These leavening agents are especially important for quick breads, cakes, muffins, and biscuits where fermentation with yeast is not required. The slide also lists the major chemical leavening agents. These include baking powder, baking soda, cream of tartar, and ammonium bicarbonate. Each of these ingredients has its own mechanism of releasing carbon dioxide and is selected according to the type of bakery product being prepared. Chemical leavening agents make bakery production faster because they eliminate the need for long fermentation periods. Having understood the basic concept of chemical leavening agents, let us now study baking soda in detail. Baking soda is chemically known as sodium bicarbonate. It is one of the simplest and most commonly used chemical leavening agents in bakery products. However, baking soda cannot work efficiently on its own. It requires the presence of an acidic ingredient such as curd, lemon juice, vinegar, cream of tartar, or other food acids. When baking soda reacts with an acid in the presence of moisture, carbon dioxide gas is released. This gas expands the batter during baking, producing soft cakes, muffins, cookies, and quick breads. The slide also highlights an important precaution. If excess baking soda is added, it may leave an unpleasant alkaline taste, produce excessive browning, and even give the product a slightly yellow color. Therefore, baking soda should always be used in the correct proportion. Next, let us understand baking powder, another commonly used chemical leavening agent. Unlike baking soda, baking powder already contains both an alkali and an acid along with starch. The starch acts as a drying agent, preventing the acid and alkali from reacting during storage. Once moisture is added and the batter is heated, the acid reacts with sodium bicarbonate and releases carbon dioxide gas. This makes baking powder a complete leavening system that does not require an additional acidic ingredient. The slide also explains the different types of baking powder. Single-acting baking powder releases gas immediately after mixing with water. Double-acting baking powder releases some gas during mixing and the remaining gas during baking. Because of this two-stage action, double-acting baking powder provides better volume and is more commonly used in commercial bakery products. Remember this simple difference. Baking soda needs an external acid, whereas baking powder already contains one. Another important chemical leavening agent is ammonium bicarbonate. Ammonium bicarbonate decomposes during heating and produces carbon dioxide, ammonia, and water vapor. These gases expand rapidly, making bakery products light and crisp. It is mainly used in products such as biscuits, crackers, and cookies, where the product is thin enough for the ammonia gas to escape completely during baking. However, it is generally not suitable for thick bakery products because any trapped ammonia may produce an undesirable odor. Therefore, its application is limited mainly to low-moisture bakery products. This is an important point that is often asked in examinations. Moving further, let us understand the role of salt in bakery products. Although salt is added in relatively small quantities, it performs several important functions. The first function is flavor enhancement. Salt improves the overall taste of bakery products by balancing sweetness and enhancing other flavors. The second function is strengthening gluten. Salt improves the strength and elasticity of the gluten network, making the dough firmer and easier to handle. Another important function is controlling yeast fermentation. By slowing excessive yeast activity, salt ensures controlled fermentation and uniform dough development. Salt also contributes to better crust color and helps improve the texture of the final baked product. Finally, it slightly improves shelf life by reducing the growth of certain microorganisms. This clearly shows that salt is much more than just a seasoning ingredient.
Now, let us understand the different classifications of salt used in bakery and food preparation. Although all salts primarily provide sodium chloride, they differ in grain size, mineral content, texture, and culinary applications. The first type is table salt. Table salt is the most commonly used salt in households and bakeries. It has fine, highly refined crystals and is usually iodized to provide iodine, an essential nutrient for human health. Because of its uniform particle size, it dissolves quickly and distributes evenly throughout doughs and batters. The second type is kosher salt. Kosher salt consists of larger, coarse crystals and generally contains no additives. Its larger crystal size makes it easier for chefs and bakers to control seasoning during food preparation. It is especially valued for its clean taste and ease of handling. The third type is sea salt. Sea salt is obtained by evaporating seawater. Unlike highly refined table salt, it retains small amounts of natural minerals that may contribute subtle differences in flavor and texture. Sea salt is commonly used both as a baking ingredient and as a finishing salt to enhance the appearance of bakery products.
Now let us move to another important group of bakery ingredients, flavoring agents. Flavoring agents are added to improve the aroma, taste, and overall sensory quality of bakery and confectionery products. The slide classifies flavoring agents into two major categories. The first category is natural flavoring agents. These are obtained directly from natural sources such as plants, fruits, spices, herbs, coffee, cocoa, and vanilla. Natural flavorings provide authentic taste and aroma while enhancing the overall quality of the final product. The second category is artificial flavoring agents. These are chemically prepared compounds that are designed to imitate natural flavors. Artificial flavorings are widely used because they provide consistent flavor, are economical, and remain stable during processing. The choice between natural and artificial flavorings depends on the type of product, processing conditions, consumer preference, and production cost. A good flavoring agent should enhance the product without overpowering its original taste. Next, let us understand one of the most popular flavoring ingredients in the bakery industry: chocolate. Chocolate is widely used in cakes, pastries, cookies, desserts, fillings, frostings, and confectionery products. Its popularity comes from its rich flavor, attractive color, and smooth mouthfeel. The slide introduces the major types of chocolate. The first is dark chocolate. Dark chocolate contains a high proportion of cocoa solids and cocoa butter with little or no milk solids. Because of its intense cocoa flavor, it is commonly used in premium bakery products and desserts. The second type is milk chocolate. Milk chocolate contains cocoa solids along with milk solids and sugar. It has a sweeter and creamier taste, making it suitable for cakes, cookies, and confectionery products enjoyed by all age groups. The third type is white chocolate. Unlike the other varieties, white chocolate contains cocoa butter but does not contain cocoa solids. Its smooth texture and mild flavor make it ideal for decorations, coatings, and premium confectionery products. Different chocolates are selected depending on the flavor, color, sweetness, and texture required in the final product. Moving further, let us study spices used in bakery products. Spices are natural flavoring materials obtained from different parts of plants such as seeds, bark, roots, fruits, flower buds, and many others. Besides enhancing flavor, many spices also contribute pleasant aroma and possess antioxidant and antimicrobial properties. Some commonly used bakery spices include cinnamon, cardamom, cloves, nutmeg, ginger, and allspice. Each spice provides its own characteristic flavor profile. For example, cinnamon gives a warm, sweet aroma that is commonly associated with cakes, buns, and cookies. Cardamom provides a pleasant aromatic flavor and is widely used in traditional Indian bakery products. Ginger contributes a slightly spicy taste and is an important ingredient in ginger biscuits and cookies. The correct combination of spices greatly enhances the sensory quality of bakery products. Before we proceed, think about your favorite bakery item. Much of its unique taste often comes from the careful selection and balance of these natural spices. Another important group of flavoring ingredients is fruits and nuts. Fruits improve the nutritional value, flavor, color, moisture, and appearance of bakery products. Fresh fruits, Dried fruits, fruit pulps, candied fruits, and fruit concentrates are commonly used depending on the product. Examples include raisins, cherries, dates, figs, pineapple, apple, orange peel, and many others. Nuts are equally important. Common bakery nuts include almonds, cashews, walnuts, pistachios, hazelnuts, and peanuts. Besides improving flavor and texture, nuts increase the protein, healthy fat, vitamin, and mineral content of bakery products. They also provide an attractive appearance and a pleasant crunchy texture. Selecting high-quality fruits and nuts significantly improve both the nutritional value and consumer acceptance of bakery products. With this, we have reached the end of today's lecture. Let us quickly recap what we have learned. We began by understanding the different types of wheat and their applications in bakery products. We then studied the structure of the wheat grain and explored how flour quality influences dough performance and final product quality. Next, we discussed the various types of flour and their specific uses. After that, we learnt about milk products, yeast, and the complete fermentation process, along with the different forms of commercial yeast. We also understood chemical leavening agents such as baking soda, baking powder, and ammonium bicarbonate, followed by the important functions of salt. Finally, we explored flavoring agents, chocolate, spices, fruits and nuts, and understood how they improve the flavor, texture, appearance, and quality of bakery and confectionery products. The key message from today's lecture is that every ingredient has a specific scientific function. Successful baking is not simply about following a recipe, it is about selecting the right ingredient in the correct quantity to achieve the desired quality. If you found this lecture helpful, please like the video, share it with your friends, and subscribe to our channel for more educational content on food technology, dairy technology, and bakery science. If you have any questions or suggestions, feel free to leave them in the comment section. Thank you for watching, and I'll see you in the next lecture.